Hey everyone, I hope you're doing well. It's Mr. Irwin coming to you with today's math lesson. Today we're going to talk about using equivalent ratios to solve problems. And our first example is on the board, or I guess on your screen. Grab a sheet of paper and work along with me. Here we go. Example number 1 says, it takes Julia 20 minutes to ride 4 miles on her bike. Use a table to figure out how long it would take her to ride 24 miles. So essentially, to start solving these problems, we want to find a rate. We want to find two values that are being compared in this scenario. And in our very first sentence, we see that it takes Julia 20 minutes to ride 4 miles on her bike. So we know we are comparing minutes to miles. So I'm going to create a table. The top of my table is going to represent minutes, and the bottom of my table will represent miles. And initially, I know Julia spends 20 minutes to ride 4 miles. Take a moment if you need to, pause the video and get yourself a table built like the one you see on the screen. And now our ultimate goal, the question says, how long would it take her to ride 24 miles? Well, miles is on the bottom, so my goal is to get to 24. Now, we have lots of options for this. One way, multiplicatively, if you can figure it out, how do I move from 4 straight to 24? Well, if you know your factors, you'll know that 4 times 6 is 24. Now, to keep these equivalent, that means I would do the same thing to the top. 20 times 6 gives me 120. So I know for Julia to ride 24 miles, it would take her 120 minutes. Now you have lots of options to solve this problem. Say you didn't see the times 6. Let's do another table of minutes to miles. Same start, 20 to 4, with our goal being to get to 24 miles. Another option is to use a unit rate in between. So we know, we talked from our previous lesson, a unit rate is comparing to 1. So could I figure out how many minutes it would take her to ride 1 mile? Well, how do I go from 4 to 1? We divide by 4. So let's do the same thing to the top. 20 divided by 4 is 5. So I would know it would take her 5 minutes to ride 1 mile. And now that I have a unit rate, it's very easy to go from 1 to anything because we would just multiply by that value. So to get from 1 to 24, I am multiplying by 24. I'm going to do the same thing to the 5. Guess what 5 times 24 is? Yeah, you're right, 120, just like we said in our previous example. So you have multiple options to solve these problems. You're looking for common factors, common multiples, any way you can work through these equivalent rates to solve the problem being asked. All right, example 2. Dustin read 12 pages in 20 minutes. Use a table to figure out how many pages Dustin would read in 50 minutes. So again, we're going to start with the table. In this case, we're comparing pages in minutes. So I have pages as my first row. Let me grab a new pen. And minutes as the bottom row of my table. Initially, 12 pages in 20 minutes. Our goal is to get to 50 minutes. So we are looking for the value up here. Now, jumping straight from 20 to 50, that's tough to do multiplicatively. There is a value you could multiply 20 by to go straight to 50. But a lot of students don't recognize it because it is a decimal value. So if you need to, give yourself a jumping point. What is a common factor between 20 and 50? Well, because they both end in 0, I know they're both divisible by 10. So let's make 10 a stepping stone. How do I go from 20 to 10? Divide by 2. And then how do I go from 10 to 50? multiply by 5. And now I'm going to continue that or do that same sequence to my number of pages. First, dividing by 2. 12 divided by 2 is 6, meaning that Dustin would read 6 pages in 10 minutes. And then I continue. Next, we multiplied by 5. 6 times 5 is 30. So in 50 minutes, I would expect Dustin to read 30 pages. Let's set up another table. Complete this problem another way. Another option, 12 pages in 20 minutes. Our goal to get to 50 minutes. You can use unit rate if you want to. To go from 20 to 1 is dividing by 20. And to go from 1 to 50 is to multiply by 50. Up top, we're going to do the same thing. 12 divided by 20 gives you 0.6. And then we're multiplying by 50. 0.6 times 50, again, is 30, just like we calculated before. I want to show one other way to get where we need to get. Pages in minutes, one more table. Our initial rate, 12 pages in 20 minutes, trying to get to 50 minutes. If you found the factor that took you straight there, you could take 20, you could multiply it by 2.5, and that would get you straight to 50, and that allows you to jump straight here with the pages. Guess what 12 times 2.5 is? Yep, it's 30, just like we calculated previously. It does not matter to me which method you use, if you use a stepping stone, or if you use a unit rate, or if you can find the relationship to get you there in one jump. It does not matter to me as long as you are completing all of your math correctly and finding equivalent values to solve the problem. All right, boys and girls, on the screen, I have 2 more situations. I want you to use one of the methods discussed in the previous tables to solve the problem that's being asked. Go ahead and pause the video. Once you've completed both problems, hit play again to check your work to see how you did. All right, let's go over your work. Number 1, Lance mowed 4 lawns in 7 hours. Use a table to figure out how many lawns he would mow in 35 hours. So in this problem, we are comparing lawns to hours. And our initial rate is 4 lawns in 7 hours. 4 lawns in 7 hours. Question wants to know how many lawns would he mow in 35 hours? Hours is on the bottom, so 35 goes on the bottom. If this was me completing the problem, 7 to 35 should be a pretty simple jump because 7 times 5 is 35. We're going to perform that same calculation to the top of our rate. 4 times 5 is 20. So in 35 hours, we would expect Lance to mow 20 lawns. All right, number 2, Harold spent $7.05 on 4 gallons of gasoline. Use a table to figure out how much 30 gallons of gas would be. So the 2 quantities we are comparing in this table are dollars to gallons of fuel. Initially, he spends $7.05 for 4 gallons, and we are trying to get or find how much it would cost for 30 gallons of gasoline. Jumping straight from 4 to 30 is possible, but it's kind of difficult. So maybe you want to find an easier jumping point, a common factor between 4 and 30. I know they're both even, so they're both divisible by 2. Let's use 2 as a stepping stone. To go from 4 to 2, I'm going to divide by 2, because 4 divided by 2 is 2, and then I can jump easily from 2 to 30 by multiplying by 15. 2 times 15 is 30. Now let's complete that same sequence for our $7.05. Probably want a calculator for these calculations. First off, we're doing 7.05 divided by 2. And you can't see it because of my glare, but you should get 3.525. And then to go here to our final jump, we're multiplying that by 15. So 3.525 times 15 you get 52.875. And now when I label that, because that is dollars, $52.875. I know for cents, after the decimal point, I only usually keep 2 digits for cents. So we're going to round. Right now we have 87 cents followed by a 5. A 5 would round. Remember, 5 and above, give that 87 a shove. So we would round this up to $52.88. All right, one last example I want to talk about. And there will be situations where you are just given a table of values with a bunch of holes in it. And it's going to be your task to use equivalent ratios to fill in the blanks. So our first table, whenever you're given a table, is to find a completed ratio. So the only place I have a completed ratio here is 2 to 9. So that's going to be my starting point. Now you're looking for common factors, common multiples, ways you can multiplicatively move between your rates or ratios. I see a relationship here to go from 2 to 6. Going from 2 to 6, I would multiply by 3, which means I'm going to repeat the same process down below here with the 9. 9 times 3 means this gap becomes a 27. Now I have a 36 in this row. Should be a pretty easy jump from 9 to 36 because 9 times 4 is 36. Repeating that up top. 2 times 4 would give me a value of 8 to place here. Now we have options to get to this 12. You could go 2 to 12 because 2 times 6 is 12, or you could go 6 to 12 because 6 times 2 is 12. It's totally up to you. I'm going to go from the 6. 6 times 2 is 12, so now I'm going to take the 27 times 2, and that gives me a final answer of 54. All right, final table is all yours to complete on your own. Copy it down, please. Use common factors or multiples to find the equivalent ratios in this table. Pause the video while you work, and when you're done, hit play to check to see how you did. All right, let's check your work. Our completed ratio is 8 to 12, so that's going to be our starting point. Jumping from 8 to 4 is our first jump, and you can do that through division by 2. So 8 divided by 2 is 4. So we're going to do the same thing with the 12. 12 divided by 2 gives me 6. Next, I want to jump from 4 to 24 because 4 times 6 is 24. We're going to do times 6 at the bottom then as well. 6 times 6 is 36. And then to get to 132, I think probably the easiest jump is from the 12. If you remember your third grade multiplication facts, 12 times 11 is 132. So coming back to the 8th end and multiplying it by 11, 8 times 11 gives us 88 to fill in that blank. Please complete the independent practice assignment for equivalent ratios or ratio tables. Take a picture of your work and upload that file for submission. See you guys next time.